of voltage sources, vector of current sources. So in our previous example, I have shown only one voltage source and one current source. Maybe someone is trying to enter. So let me see. So only one voltage and only one current source I have shown. Now to show that now I have taken another example where a number of sources are included, 3 voltage sources and 3 current sources. Only my intention is to show where the sign of the source will be positive and where it will be negative, and remaining portion is already known to you. I have shown you the example, so I think that part is clear to you. So I have not repeated that part here. So in this circuit, which is simply a modification of the previous circuit, you can say, okay, because I rather chosen to keep the example small. That's why the circuit is rather the modification, a variation of the previous circuit. So here there are 6 elements. It is 1, then 2, the current source with parallel resistance 3, then this voltage source with series impedance 4th, 5th is the current source with parallel impedance, combination of resistance and inductance, and 6th one is a voltage source with series resistance. So these are the 6 elements. Okay, so I have formed the graph here also and chosen a direction of each element of the graph. So graph is oriented graph here. Every element assigned a direction like this. Okay, now let us show the voltage source vector and current source vector. Vs is the voltage source vector. Then you see that for element 1, this is basically a capacitor, so no voltage source, it is 0. Element 2, this is a voltage source with series inductance. Okay, and this is the direction of the source. Now the positive direction of current through the branch is actually in the opposite direction. It is plus and minus, means current will actually come out from this terminal. In this direction will be the flow of current. Since this direction is opposite to the chosen direction, or this assigned direction to the graph is opposite to the direction of natural current flow, so that's why this source will be a negative source, so minus 30 volt, minus 30. Element 3, this is a current source, this total combination is a current source, so no voltage source is there, is 0. Element 4 is again a voltage source with series impedance. This is the positive polarity and negative terminal of the source, and direction assigned is this one. So this direction and natural direction of current through the branch, because of this source, this is the natural direction of current. That means current should come out of this type of the positive terminal. So here you see that this is a positive source, plus 20 volt. Then element number 5, again this is a current source, so no voltage source is there, it will be 0. Element number 6 is again a voltage source with this terminal positive and this terminal negative. What is the chosen direction in the graph? It is in the opposite direction. So this source again minus 50 volt will be the source value here in the voltage source. Okay, so this is how we shall actually form the voltage source vector. Direction will be positive if the natural direction of current flow through the source because of the voltage source is same as the direction assigned to the element of the graph. Okay, and if they differ, if they are opposite, then the direction will be minus. Now come to the current source. There are 2 current sources at element number 5 and element number 5 and element number 3. So 1, 2 and 4, 1, 2, 4, 6, these 4 elements are not having any current sources, so those elements will have 0 entry. So 1, 2, 4, 6, 0 entry. Somebody again is trying to enter, so let me see. Okay. So 1, 2, 4 and 6, these are having no current sources. Current source is there in element number 3. This is the current source, and element number 5 also is the current source. Now, graph or the graph in the element in the graph representing this source is this one, element 3. This here the direction of is considered to be upward from 4 through 2, from node 4 to 2. That means here from node to 2. But actual current of the current source will actually flow in the opposite direction. It will be 15 ampere current coming out from here will flow through the internal impedance from 2 to 4. So it is opposing this current source. Basically, this element is actually representing the internal impedance of the source. Therefore, through the internal impedance, because of this source, current should flow from terminal or node 2 to node 4, but actually the direction considered here is, or direction assigned here is from 4 to 2, that's why it will be negative source. So minus 15 volt. Okay. Third element, current source is minus 15 ampere. Then fifth element here. This is the internal impedance and this is the graph. Element in the graph is this one. The direction is assumed to be from 4 to 3, that is from here to here. And in which direction current will flow through this internal impedance of the current source, it will be from 4 to 3. This current in this, it is flowing in this direction, so it should be flowing from 4 to 3 through the internal impedance. So that means the assumed direction of current through the element is same as the current that will be there through the internal impedance. It is from 4 to 3. That's why this source of 10 ampere will be a positive source. 10 ampere is a positive source. Okay. Now this is how we can form the voltage source vector and current source vector. Other matrices ZB, how to form ZB already we have shown in our previous example. So I think here it will be not a problem for you. Okay. So now we'll see whether there is any question in this part or not. If there is no question, then I shall move on to the next part. So with this, the discussion on graph theory will be completed. Okay. And if there is any other question today, I shall obviously discuss those things. And after the completion of the whole course, then if you have any problem to discuss, you can mail me those problems, then I shall arrange classes and discuss all those things. Okay. So now up to this is the graph theory. Today this part is only this part I have to discuss on graph theory, and then I shall move to other topic. Now if you have any question, you can ask me that on today's content. Bolo.
হ্যালো স্যার।
হ্যাঁ বলো।
স্যার বলছিলাম এখানে যে কারেন্ট সোর্সটা আছে, তো ওই কারেন্ট সোর্সের সাথে প্যারালালের ওই ব্রাঞ্চে যদি ওখানে হচ্ছে ওই রেজিস্ট্যান্স আর হচ্ছে যে ইন্ডাক্টরটার মাঝখানে যদি মানে হচ্ছে ওই পয়েন্টটা থেকে যদি হচ্ছে আরেকটা ব্রাঞ্চ যে বেরোতো, তো মানে সেক্ষেত্রে কি ওই দুটো ব্রাঞ্চকে হচ্ছে যে আলাদা আলাদা যে এলিমেন্ট ধরতাম, ওই যে কারেন্ট সোর্সের ব্রাঞ্চটাকে?
তখন কারেন্ট সোর্সকে তো আর এইভাবে রিপ্রেজেন্ট করা যেত না, কারণ কারেন্ট সোর্সকে রিপ্রেজেন্ট করতে গেলে কারেন্ট সোর্স মাস্ট হ্যাভ এ প্যারালাল ইম্পিডেন্স। সেক্ষেত্রে প্যারালাল ইম্পিডেন্স আমরা কি ধরবো? ইট শুড বি ইনফাইনাইট, আর তো কিছু করার নেই সেক্ষেত্রে। অর্থাৎ তুমি যদি ধরো এখানে একটা ব্রাঞ্চ ধরো, তাহলে দ্যাট মিনস দিস এলিমেন্ট প্লাস দিস এলিমেন্ট is actually representing the internal impedance of the source. Okay, that type of representation is really not desirable. That is not done. Whenever we represent a current source, practical current source, there will be some impedance. In that case, what we may consider? We may consider that basically there is an infinite impedance from an ideal current source in that case, and an impedance from 4 to 3 is available, whose value is obviously infinite, and this is a separate branch, this is a separate branch with a node here, and another branch may be count going from here, maybe like this. All right.
Yes, sir.
আর কিছু কোশ্চেন আর কারো থাকবে যদি থাকে? So if you have no other question, then or you go through this, and then I shall actually later on I shall this we shall consider problem from the whole course. Okay, there I shall be discussing more examples, and you can also send me questions, send me examples which are to be discussed in the class, on the online class. Okay, now let us move to the next content, which is basically in the 2 years ago, this was basically a part of first year course, as I mentioned yesterday in our previous class. But these courses, these topics actually are not included in the new first year course, because new first year course is a course uniform to all. Everyone is studying that course, so these things are not necessary for other people. That's why these things are not included in the first year courses. So to accommodate those portions, we shall be now discussing those remaining things which are not actually discussed in your first year courses. Okay, these are very simple. When I discuss, you will see that some of the things already you know. Okay, that means the knowledge required to understand this is already known to you. We shall now discuss this in a formal manner. This is the thing basically. Okay, so what I shall do, I shall actually discussing some theorems, okay, which I have not discussed previously in in this course. Okay, so that theorem is the Millman's theorem. You see that basically this is nothing but an application of source transformation that I have mentioned, or we have studied previously. What is this Millman's theorem? According to this theorem, a number of parallel connected voltage sources having open circuit voltage EI and series impedance ZI may be represented by a single voltage source E in series with impedance Z. Okay, if there are a number of parallel connected sources with generated voltage and impedance in series, then you may represent those sources by a single source and single series impedance. What is the single source value? It is equal to summation EI YI. I is from 1 to n on all the n number of sources that are in parallel, divided by summation of YI. YI being the admittance of the source, series admittance of the source. And what is Z? Z is obviously equal to 1 upon the sum of admittances of all the sources. So this is the theorem, Millman's theorem. Now let us see how to obtain this expression. Then you will understand that this Millman's theorem basically is nothing but an application of source transformation theorem that we already know. Transformation of how to convert voltage sources into current sources into voltage sources. Simply that has been implied and represented as in the form of a theorem. Okay, say we have a number of sources connected in parallel. Sources are E1 with series impedance Z1, E2 with series impedance Z2. In this way, say En with series impedance Zn. Okay, n number of such sources are connected in parallel between terminals A and B. Then how can we represent this voltage source Z1 with series impedance E1? I can represent this as a current source as E1 by Z1 with parallel impedance Z1. Okay, this is the direction of the current. So do you know how this source may be converted into this current source? Similarly, E2 will be converted into another current source E2 by Z2 with parallel impedance Z2. In this way, all other sources will be converted into current sources, and finally, say En by Zn is the current source here with parallel impedance Zn. Okay, this is a simple source transformation we can apply to each and every source. Okay, now you obtain the equivalent current source for all. What is the equivalent? Equivalent is EI E1 by Z1 in parallel with E2 by Z2 in parallel with all other sources En by Zn means all the currents will be added up. We can say that E1 by Z1 means E1 into Y1, the inverse of Z means admittance, so E1 Y1 or EI YI summation will be the resultant current source. Okay, sum up all the currents, sum up all the current sources, current of all the current sources, that will be EI YI summation over I equal to 1 to n, summation of all current sources. Okay, then what will the parallel impedance? This impedance, this impedance, this impedance, parallel impedance. If I write them in the form of admittance, then what will be there? It is Y1, the reciprocal of Y, Z1 means Y1, then Y2 in the form of admittance also we can write. And we can say that this is, if admittances are connected in parallel, what is the resultant admittance? The summation of admittances. So summation of 1 upon summation of admittance. Total admittance will be summation of admittances in the form of impedance, it will be reciprocal of that. Okay, so Y1 basically is 1 upon Z1 or YI is basically 1 upon ZI. So when all admittances are connected in parallel, resultant admittance is the summation of all these admittances, meaning summation of YI. What is the impedance corresponding to that? Reciprocal of that. So this is how you can obtain the single source equivalent of all these sources. Okay, this is the current source, sum of all currents, and this is the parallel impedance, parallel of all impedances. Okay, maybe written in this form also. Okay, now again you can convert it into a voltage source. This is now in the form of a current source. Now convert it into a voltage source. How to convert it? Multiply this current by this impedance to obtain the voltage. Okay, and impedance will be connected in series. So if the impedance is connected in series, then it will be 1 upon root over 1 upon summation over yi, I equal to 1 to n, and resultant impedance, resultant voltage will be summation of ei yi divided by summation of yi. Okay, this is how simply by applying source conversion to each and every source here, and finally converting current source to voltage source, obtaining a single source equivalent. This is the result, and we can say that this is nothing but the Millman's theorem that is being stated here. That has been stated here that a number of parallel connected voltage sources having open circuit voltage EI and series impedance ZI may be represented by a single voltage source and single impedance where value of E and value of Z are given. Okay, so you see that we have done nothing but the application of source transformation. I think this is very clear because already we have studied source transformation at the beginning of this course. Is it clear? Is it clear? Any question here? It should be very easily understood by all of you because long back at the beginning of this course, we have studied, we have discussed all this source transformation and applied two different examples also. Here in this particular case where a number of sources are connected, voltage sources are connected in parallel, we have to apply this source transformation and obtain a single voltage source with series impedance. Okay. All right. Any question up to this? বলো কোনো কোশ্চেন আছে কারো? Anybody having any question? And if no question is there, then let us continue with the same theorem, Millman's theorem. Then it is now applied to a series connected current source. How? A number of series connected current sources having source current II with parallel admittance YI may be represented by a single current source I with parallel admittance Y. Okay, a number of admittance current sources are connected in series. You can represent that current source by a single current source with parallel admittance. How? Again, by applying a source transformation. And what will be the value? I will be, resultant current source will be summation over II divided by YI, summation for I equal to 1 to n, all the sources connected in series, divided by 1 upon Yi, summation of 1 upon Yi. 1 upon Yi means impedance of each source. Impedance are summed up, okay, for all the sources. So capital Y means, or Y means, this is the 1 upon summation of 1 upon Yi. That means this is the impedance, sum of all impedance, reciprocal of that is the admittance. This is Y. So let us see how we can apply source transformation here and how we can obtain this thing. Now let us assume that we have a number of sources, current sources connected in series. These sources are all practical current sources with actual current sources with I in parallel with Y. So II is in parallel, I1 is in parallel with Y1, I2 in parallel with Y2, in this way IN in parallel with YN. So this current source may be represented by this voltage source. How? I1, Y1, okay, I1 Z1 or I1 by Y1 will be the voltage here, and Z1 is the series impedance, means 1 upon Y1 is the series impedance. Similarly for this source, and for this source, IN divided by YN is the value of EN, and 1 upon YN is equal to Zn. They are connected in series. Okay, these sources are connected in series, current sources. So we have converted them into voltage sources, and their connection remains in series, so shown in series. Now, when you have a series connected current voltage sources, now obviously you know what is the resultant source. It is a summation of all sources. So E1 plus E2 plus E3 up to En is the resultant voltage. Okay, E, summation of all voltage sources. Means what is EI? EI means II by YI, summation for all sources. And what is Z? Z will be the summation of all impedances. So Z is the summation of Zi equal to 1 to n. What is Zi? Zi is 1 upon Yi. That means reciprocal of admittance is the impedance. Okay. So this is how you can represent them in a voltage source with series impedance first. Then we want to go back in the form of current source, because originally it was a current source. Now convert this voltage source into a current source again. How? This voltage divided by this impedance will be the current. So I is E by Z. Put the value of I, put the value of E, put the value of Z. And what is Y? Y is 1 upon Z. So put the value. So this is how you can actually convert number of current sources connected in series into a single current source with the value I equal to summation over I equal to 1 to n II by Yi. Y is the admittance of IS source, okay, parallel admittance of IS source, and divided by summation over all current sources I equal to 1 to n 1 upon Yi. That means impedance of all sources taken the summation here. Okay, so this is the Millman's theorem. So Millman's theorem states you how you can represent a number of current sources into a single current source, a number of series connected current sources into a single current source, number of parallel connected voltage sources into a single voltage source. Okay, is it any question? Is there any question? Anybody of you having any question now? Because these are very simple things, perhaps, because already the source transformation was discussed long ago. You should be in a position to understand this automatically, because we have solved questions, we have solved examples, discussed these issues previously. Now I am stating all these things in the form of theorem only. Bolo. Anybody any question? কারো কোনো কোশ্চেন আছে, or it is understood by all? Bolo? So if all of you would understand, then let us proceed. So say this is the example, okay? The number of voltage sources connected in parallel, and in parallel with them a load is given. You have to find out the current. I think you can easily find out the current because all these voltage sources you may represent as a single voltage source like this here, single voltage source with series impedance. Now across that this load is connected, you find out what is the current. So you can solve it. The answer is given here. I think you can easily solve it. So you will be solving this. I hope you will have no problem in solving this, in getting this answer. You try and tell me if there is any problem, then I should discuss. Okay. Now second is the Telegen's theorem. Telegen's theorem is you can say it is the most general purpose theorem. Okay, what is that? It is also very simple. Okay. Now, in any electrical network, the sum of instantaneous power in all branches is 0. That means if you take the summation of instantaneous power, what is instantaneous power? Power is the product of voltage and current. So sum of product of voltage and current of all the branches in a network is equal to 0. This is the theorem. Okay, that means sum of instantaneous power of all the branches in a circuit is 0. That means whatever power is being generated, that much of power also will be consumed. That means you can say that this is nothing but the statement of conservation of power. So Telegen's theorem therefore is also sometimes same. This is the theorem of conservation of power. Okay. So in an electrical network, the sum of instantaneous power in all branches is 0. That means summation of Vk k from 1 to n in m number of elements are there in the network, then it will be equal to 0. Where Vk and Ik are the branch voltage and current respectively. Vk is the voltage across the branch, Ik is the current flowing through the branch. There is one condition, however. What is the condition? Provided KVL and KCL are satisfied by the branch voltage and current. This KVL and KCL must satisfy the Kirchhoff's voltage law and current law. So in any circuit, obviously they should follow Kirchhoff's voltage and current law. That means if they follow Kirchhoff's voltage and current law, then summation of Vk Ik for any circuit, summation of Vk Ik means summation of instantaneous power is 0. Okay. So Telegen's theorem is the most general theorem and applicable to all type of networks, including linear and non-linear, active or passive, time varying and time invariant. That means this is the only theorem that is applicable to all type of branches, including linear and non-linear, okay, time varying and time invariant, okay, all type of, for passive and active, all type of elements are covered here. Okay, simply the condition to be satisfied is that the currents must satisfy the Kirchhoff's current law, then voltages must satisfy the Kirchhoff's voltage law. Okay, the only requirement is the satisfaction of KVL and KCL. Okay, now let us consider an example. Simple example. Say a simple circuit is there, having a voltage source, then an impedance, another impedance here, another impedance here, and this is the impedance. Okay, so there are 1, 2, 3, 4, 5, and 6. As if 6 elements are connected, 6 branches are there in the circuit, and the values of voltage and currents are given here. Okay, V0 means this source value is given with this terminal polarity positive, this terminal having negative polarity, voltage is 20. V1 is this voltage with this terminal positive and this terminal negative, it is 16 volt. V2 is 2 ohm with this terminal positive, this terminal negative. This is the direction of current flow. So current obviously will flow from higher to lower potential, positive to negative terminal, positive to negative terminal. Here also positive to negative terminal current is flowing. V4 is given to be 14 volt and I4 is also given. Here it is 4. V2 is 2 volt. This volt is 2 volt This terminal positive, this is negative, and I2 is also given, it is 2 ampere. I3 is 14. This is I3, 14. And what is V3? V3 is given 4. So in this way, all voltages are given, all currents are given. So let us now verify that all these voltages, they are satisfying Kirchhoff's voltage law. So consider one loop at a time, ACBA, this loop, ACBA. So you take the summation of algebraic sum of voltages in the loop, V0 minus V1 minus V3. So V0, then minus V1 minus, sorry, V0 minus V1. So negative to positive, rise in potential V0, plus to minus drop in potential minus V1, plus to minus drop in potential minus V3. The loop is closed, so sum is 0, and it is, we are getting 0. That means these voltages V0, V1, V3, they are satisfying Kirchhoff's voltage law. Similarly, the loop CDBC, CD then BC, this loop. Here, what you can write, CDBC, V3, this voltage, rise in voltage, V3, then plus V2, again minus 2, plus terminal is rise in voltage, V2, then minus V5, okay, minus V5. So closing the loop, so here the values are 4 plus 2 minus 6, that means 0 again. So this loop also, the voltages are actually following Kirchhoff's voltage law. Similarly, considering this loop here also, it is V1, then plus 2 minus V4, V1 minus V4, and then minus V2. V1 minus V4 minus V2, put the values, you'll see that it is 16 minus 14 minus 2 equal to 0. So that means the given voltages, they are satisfying Kirchhoff's voltage law. Now, given currents, current direction given, current obviously will flow from positive to negative terminal. That means in the direction of current, this is the direction of current, this is at a higher potential, this is a lower potential. While assigning this direction, direction of branch current, we shall actually follow this convention, load convention. That's why what this source also, it is assumed that current is flowing in this direction from higher to lower terminal of the, or from positive to negative terminal of the element. Okay, so now KCL you apply at node A. Where is node A? Here. What are the currents? Here the current is I0, here the current is I4, here the current is I1. So it is I0 is going out of the node, say minus I0. I1 is also going out of the node, minus I1. Then I4 is also going out of the node, minus I4. Put the values, it is 0. At node C, currents that are meeting is I3 going out, I2 coming, and I1 is also entering. So I1 and I2 entering, I3 is going out. So I1 and I2, they are entering current positive, I3 is going out, so it is negative. Putting the value, again you are getting 0. That means Kirchhoff's current law is satisfied here by the currents given. Kirchhoff's current law is satisfied at node C by the currents given. At node D, what are the currents? I2 going out, I5 going out, and I4 entering. So I4 is positive, minus I2 minus I5, I4 positive, minus I2 minus I5, putting the values 0. So all currents given here satisfying Kirchhoff's current law. All voltage given in the circuit are satisfying Kirchhoff's voltage law. Therefore, you can say that the diligence theorem will be satisfied here. That means summation of Vk will be equal to 0. Let us verify. Now you write, you said, what is the total instantaneous power? V0, I0. So it is positive, negative, current is in this direction, V0, I0. Then V1, I1. Okay, in this positive, negative, current in this direction. Then V2, I2. Positive, negative, current in this direction, V2, I2. Then V3, I3. I3 in this direction, this terminal positive, this terminal negative. V4, I4, this direction current, it is positive, it is negative. All right. V5, I5, this is positive, this is negative, so current should be in this direction. So sum of V0, I0, V1, I1, V2, I2, V3, I3, V4 I4, V5 I5. You take the summation, put the values, and you are getting 0 here. That means sum of instantaneous power of all the elements of the circuit is 0. That means you can say that the Televen's theorem we may interpret as the conservation of instantaneous power in a network. Sum of power delivered from all sources must be equal to that consumed by the passive element. That means some of these are sources, they are delivering power. What about the passive elements? They are load, they are consuming power. So power delivered by the source must be consumed in the circuit. Okay, this is what, this is also, we understand that this is the fact. That means in any circuit, there cannot be any unaccounted amount of power. It will be such that you cannot actually, you are not getting the account of current. A power is being generated, that is being consumed, some power is lost, always it will be there. Okay, generated power will be equal to the load power plus loss of power. If there are other connecting wires, there the power loss will take place. So those are also to be included. So if you include everything, then always you will see that sum of instantaneous power in the circuit, including sources and loads, everything will always be equal to 0. Okay, so this is Televen's theorem, and this is obviously the most general theorem applicable to any type of circuit. Need not be linear only. It is valid for linear and non-linear. That means whatever may be the circuit, all circuit elements always will follow Kirchhoff's current law and voltage law. And if Kirchhoff's current law and voltage law are satisfied, Televen's theorem will be applicable, and therefore it is applicable to all type of circuits. Is it clear? Any question here up to this? Very simple theme, very simple theorem. Rather they are fit for clear courses. হ্যাঁ বলো
স্যার এখানে যে বলছিলাম এখানে হচ্ছে যে এই প্রবলেমটাতে কি হচ্ছে ওই ভোল্টেজ সোর্স বা যে কারেন্ট গুলো যে ডিরেকশন গুলো কি ওগুলো কি যে প্রথম থেকে মেনশন করা আছে, মানে যে ভোল্টেজ সোর্সে যে পোলারিটি বা যে কারেন্ট সোর্সের যে ডিরেকশন
করা আছে এবং সেই অনুযায়ী ভ্যালুগুলো দেয়া আছে।
আচ্ছা, কারণ এখানে যে লেফটে যে সোর্সটা আছে তো ভি নট থেকে তো যে কারেন্টটা তো বেরোনোর কথা, বাট
হ্যাঁ এটা উল্টো দিকে, সেজন্য -16 বলা আছে।
হ্যাঁ মানে আচ্ছা ওটার জন্য -16 হয়ে যাচ্ছে আর কি, মানে পরে গিয়ে মানে 16 ইন্টু মাইনাস, আচ্ছা 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 ঠিক আছে, আই নট -16 আছে, ঠিক আছে।
আসলে কি হতো, আসলে তো এটা ফ্লো করতো উল্টো দিক থেকে, তো ঠিক আছে এদিক থেকে বেরোনোর কথা ছিল, তাহলে তুমি তার মধ্যেই পোলারিটিটা ধরে নিতে, তার মধ্যে না ধরে আমরা এইভাবে পোলারিটি ধরলাম, ভ্যালুটাকে চেঞ্জ করলাম, বুঝতে পেরেছো? অর্থাৎ this power is, this is the delivered power and all other power is nothing but the power consumed. বাকিগুলোর সাইন নিয়ে কোনো সমস্যা নেই, এটার সাইন নিয়ে মনে হতে পারে একটু সমস্যা, কেন এটা তো আসলে এদিকে ফ্লো করছে, কিন্তু এই ডিরেকশনে কারেন্টটা দেয়া রয়েছে এবং তার ভ্যালুটাও দেয়া আছে কিন্তু -16, মানে দিস ইজ অ্যাকচুয়ালি ফ্লোইং ইন দ্য অপোজিট ডিরেকশন। ওকে, ইজ ইট ক্লিয়ার?
Yes sir, yes sir, yes sir.
Any other question, anybody? That means what to understand from here, what to get from here is that there will be conservation of power. That means any power delivered has to be consumed, okay, by the circuit. Okay, unaccounted power kichu thakbe na. Correct? So instantaneous power, summation of instantaneous power is 0 in the circuit. So these are very simple things, and one thing is left, that is a substitution theorem. That is also very simple. Okay, and when I discuss this thing, you will see that these are obvious things, but still we are discussing. Okay, but these obvious things also are to be known formally, so that if required, you may apply these things in circuit analysis. Whenever you will be solving or you will be analyzing different type of circuit, different type of situation, then you may be in a position to apply them. Okay, it is a substitution theorem. What does it tell? Any branch in a network may be substituted by a different branch without disturbing the voltage and current in the entire network. That means you may represent a circuit branch in the form of another component. Okay, say a resistance is there. So this resistance, if the circuit voltage and currents are not disturbed, you may represent this voltage or this resistance in the form of some other parameter of the circuit or some other component of the circuit. This is the substitution theorem. That means a circuit element may be substituted by another form of circuit elements, provided the current voltage relation is not disturbed. This is the basic content of the theorem. Okay. So any branch in a network may be substituted by a different branch without disturbing the voltage and current in the entire network, provided the new branch has the same set of terminal voltage and current through as the original branch. That means current voltage will not change. Through the circuit element, same current is flowing across the elements, same voltage is available. That means you are not disturbing voltage current anywhere in the circuit. But what you are doing, you are representing one type of element by another type. So in certain situation, this will help in circuit analysis. That's why this is, you can say, this is the applicability. This is the essence of this theorem. Okay, now let us consider a simple example to make it more clear. Okay, consider that we have a voltage source of 8 volt. In series, there is a 1 ohm resistance, and then there are two parallel branches. In one branch, there is 2 ohm resistance. In the other, there is 1 ohm resistance in series with another 1 ohm resistance. Okay, these two terminals, we call them terminals X and Y. So if you solve this circuit, you will get 2 ampere current flowing through this element and 2 ampere through this element, because basically this is a 2 ohm in parallel with 2 ohm. So here current is 2 ohm, means here also current will be 2 ohm. So 2 parallel, that means there will be 1 ohm, 1 plus 1, 2. Okay, so if you divide it, there will be 4 ampere current. It is dividing into this branch and this branch. Basically 2 ampere is flowing here, 2 ampere is flowing here. Out of this 2 ohm resistance, we have divided them into two parts, and we are saying that this terminal is, this node is X, this node is Y, and between X, Y, this is 1 ohm resistance. And what is the current through this 1 ohm resistance? That is, say, IXY equal to 2 ampere. What is the voltage across? 1 ohm multiplied by 2 ampere means 2 volt is the voltage here. Now we may replace this branch IXY, but this XY, 1 ohm resistance, basically composition of this branch is 1 ohm resistance, may be replaced by some other form of component. Okay, how we can do that? Now we see that if branch XY is to be replaced by branch having different composition, the possible options, there are so many possible options we can think of. There are other options. Some of the options are shown here. That means 1 ohm between X and Y, current flowing is 2 ampere. Means what is voltage? 2 volt. So I can simply represent this by a voltage source of 2 volt. That means this is not shown, simply as if there is a voltage source of 2 volt. That means if you replace this 1 ohm resistance with the help of this voltage source, that means this voltage source is placed here between X, Y in place of this 1 ohm resistance, then the circuit solution will not at all change. Therefore, you can say that I can substitute this branch with the help of this branch, and that is the substitution theorem. Similarly, you can substitute this branch with the help of this branch having a current source. What is the value of the current source? 2 ampere. You see that here IXY is actually 2 ampere. So if you put a current source here through which 2 ampere current is flowing, that means this is delivering a current of 2 ampere, that is matching with the requirement here. Current coming out of this node is 2 ampere. This is this current entering in this node is 2 ampere. This is this current. So you can safely replace this element by this current source, or by this voltage source, or by this resistance in parallel with voltage source, where this resistance is 0.5 and this is 1 volt. You see there is no change. If you put a resistance of 0.5 ohm in series with the voltage source of 1 volt with this polarity, you will see that the current through the element will remain 2 ampere across the, so across this XY voltage will be 1 volt. Okay, but to obtain this, now we can have a generalized way of obtaining this composition like this. Say Vxy, I want to replace this in the form of a voltage source and some impedance. Okay, so Vxy, let me write as Zx, Z dash xy. That means some impedance I shall put here, through which current will be same, Ixy. This current will flow, plus this may not be equal to the Vxy. So let us actually add some voltage here. So I shall actually replace this element with the help of a voltage source and introduce some impedance. Okay. In this case, Vxy is 2 volt. You know this from this solution. Ixy is 2 ampere. That also we know from this solution. Now, if you choose to put the value of Z dash xy, that means this impedance, say we are choosing it to be 5 ohm. If you choose it to be 5 ohm, then what will be the value of E dash? It will be minus 8 volt. Okay, that means you can represent it by a 5 ohm resistance in series with minus 8 volt. So if you choose it to be equal to 3 ohm, then you will get some other value of E. If you choose it to be 15 ohm, you will get some other value of E. That means maintaining the same current and voltage relation, you will be in a position to choose the components here. Maybe a voltage source with some other impedance, maybe some current source, maybe simply a voltage source. That means you can substitute this element with the help of a several form of elements. Okay, only restriction is that you have to maintain the terminal voltage and current, okay, has to be satisfied. You cannot deviate from this condition that through this element current is 2 ampere, across this pair of nodes voltage is 2 volts. If this is maintained, then you can represent it by any combination which satisfies this relation. Is it clear? Bolo.
Yes, sir, clear.
So these are very simple theorem. I could start discuss this thing in the first verse. Actually, what I feel that will be carries, there will be some, what you can say, that it will make some harmony should be there in the discussion. Had we discussed this in the beginning, there would have been some what you can say, loss of harmony. That's why I have not discussed all these things in the beginning. Okay, so after completion of all these things, now you see that these things are appearing to be very, very simple thing, because already all those things we have discussed, and only thing remaining to us now is the nonlinear circuit. Okay, we have discussed linear circuit, where linear circuit means elements are linear. Okay, that means when the element will be linear, that means the circuit parameter remains fixed, irrespective of the value of current or voltage, current through the element or voltage across the element. Whatever may be the voltage, whatever may be the current, the circuit parameters will remain unchanged. That means they will follow the relation. That means V equal to IR or V equal to IZ. This relation will be followed always. And impedance will be constant, or resistance will be constant. Whatever the parameter, if it is inductor, that will be constant. If it is a capacitor, that also will have constant capacity. So this is the assumption. In fact, actually what happens in circuits, we shall see that most of the elements are not linear in that sense. Say resistance changes with temperature, resistance changes with current flow. But what is the value of things? For all the circuits we have considered, they are obviously the physical resistances will actually be such that even though there are variation, that variation is so small that you can neglect them. So we are assuming that those variation, that means dependence of those resistors or inductors or currents or capacitors on current and voltage are such that though there will be some variation in the parameter values, those variations are not appreciable. Those variations are not that significant. That's why we are actually disregarding those variations. We are assuming that as if the circuit parameters are constant, they are independent of the current and voltage of the circuit. Okay, that's why we have performed all these analyses. We can apply all these theorems, as I have mentioned, except the Taylor's theorem. All other theorems, they will be applicable in case of linear circuit. So now, if you have nonlinear circuit, okay, where you can no longer neglect the variation of circuit parameter, then how will you be proceeding to solve the circuit? Those type of things we shall discuss. Okay, and that things basically, since that is completely a different issue, I would prefer to discuss those things in our next class, not today. Okay, so therefore today our discussion will be up to this only. All these theorems, we have left. Those were the content previously included in the first year courses, now newly included in the second year courses. So I have discussed those things. These things, had I discussed in the beginning of the courses, would have taken much more time. Now, since everything has been done previously, now you can take parts very easily. Those who could actually follow the earlier classes, they can follow these very easily, because all those things are, you can say, already done. All the what I can say knowledge required or understanding required to get all these things are now so simple that you can very easily grasp all those things. Okay. So now, if you have any question, you can ask me. Otherwise, I shall conclude today's lecture, and next lecture will be on nonlinear circuits. Okay, maybe one or two lectures will be required there, and then we shall perform. We shall do the remaining things. Some things are still remaining, perhaps, because while discussing some things regarding the initial conditions, I have not done that, because while discussing that mutual coupling, I haven't done the initial conditions, because there we needed to apply Laplace transform. Then Laplace transform was not done on that is due to be taken by the other teacher, Professor Tudu. Perhaps he has completed those things. So I may now discuss all those things we I have left previously. Okay, তাহলে সেইগুলো তো আমি ডিসকাস করে নিই। কাজে after I complete all these things, I shall discuss those things also, if you record it, because by this time Professor Tudu also has discussed or considered examples with maybe initial conditions and other things. So if required, I shall discuss. If you feel that if it is not required, then I shall skip simply. ঠিক আছে? All right?
Yes, sir.
বলো, কোনো কোশ্চেন আছে? হ্যাঁ, বলো কি বলছিলে?
স্যার বলছি যে এই ফিগার 44.1 এ যে 8 ভোল্ট সাপ্লাইটা আছে, তো ওইটাকে আমি যদি একটা রেজিস্ট্যান্স দিয়ে রিপ্লেস করে দিই, তা এরকম কি করা যায়?
না, এটা তো একটা সোর্স, একে রেজিস্ট্যান্স দিয়ে রিপ্লেস করলে এই রেজিস্ট্যান্সটা পাওয়ার কনজিউম করছে। ওকে, তাহলে আর কে ড্রাইভ করবে? মানে এমনি তুমি ম্যাথামেটিক্যালি রিপ্রেজেন্ট করতে পারো, কিন্তু ফিজিক্যালি কি হবে, একে যদি একটা রেজিস্ট্যান্স দিয়ে রিপ্লেস করো, তাহলে এর কারেন্টটা কত এম্পিয়ার কারেন্ট হবে? এটা 4 এম্পিয়ার, 32 ভোল্ট, তাহলে দ্যাট ইজ প্রডিউসিং 32 ভোল্ট। সো in respect of circuit condition, there will not be any problem, but in respect of applicability, there may be some question.
মানে সার্কিট সলভ করার করতে পারি
সাবস্টিটিউশন। ওকে, মানে ওই সাবস্টিটিউশনটা তুমি করতে পারো ম্যাথমেটিক্যালি, কোনো প্রবলেম নেই, বিকজ সে you are showing that there is a voltage of 8 volt across and a current of 4 ampere perhaps, তাই তো? 2 plus 2 মানে 4 ampere হবে। So 4 ampere current is being delivered in this direction. So and there is a resistance which is causing this voltage drop. Okay, but one thing is that then the direction, that means if this is positive and negative, then that direction perhaps will be compromised in that case, because if you show them resistance, and show this is the
Yes.
direction of current, then this should be higher potential, this lower potential, then that will not allow you to replace this.
ইয়েস স্যার, মানে কারেন্টের যে ডিরেকশনটা উল্টো হবে, মানে
উল্টো
ওটা
হবে।
বেরোচ্ছে আর এদিকটায় যে ড্রপ হবে মানে
হ্যাঁ,
রেজিস্ট্যান্সের অ্যাক্রসে, ওটা
হ্যাঁ,
উল্টো
তাহলে
হয়ে
that
যাবে।
will disturb the required condition. Okay.
ইয়েস স্যার।
Any other question?
সাপ্লাইটা ছাড়া বাকি যেগুলোকে রিপ্লেস করা যায়।
বাকিগুলোতে applicable হবে, কারণ সাপ্লাইটা বেসিক্যালি বেসিক নেচার তো হয় পাওয়ার কনজিউম করে, এই পাওয়ার ডেলিভার করে, কাজে কনজিউম করতে গেলে এর কারেন্ট ডিরেকশনটা পাল্টাবে কি করে, বুঝতে পেরেছো? So that becomes the question. So now we have to, while substituting, we have to see that other conditions are satisfied. If the conditions are satisfied, then there is no problem. Okay. Any other question? ওকে, বলো। যদি কোনো নাচ থাকে তাহলে আমরা নেক্সট ক্লাসে তাহলে আমি নন লিনিয়ার সার্কিটটা শুরু করব। মেবি খুব বেশি লাগবে না, হয়তো একটা ক্লাস বা দেড়খানা ক্লাস লাগলেও লাগতে পারে। দেন আর যেটা ছেড়ে এসেছিলাম আগে, যে ল্যাপ্লাস ট্রান্সফর্ম অ্যাপ্লিকেশন ইন সার্কিট, সলভিং ইলেকট্রিক্যাল সার্কিট, কিছু এক্সাম্পল ছিল, সেগুলো আমি তখন কনসিডার করিনি, কেননা যেহেতু ল্যাপ্লাস ট্রান্সফর্মটা হয়নি, ইন্টারমিডিয়েট হয়েছে। কাজে যদি তোমাদের মনে হয় যে ওইগুলো আমি আবার ডিসকাস করলে সুবিধা হবে, তাহলে আমি ডিসকাস করব। ওকে, অ্যান্ড ইফ ইউ হ্যাভ এনি আদার problem, if you have found any other problem which you could not solve, which should be discussed, then I shall discuss all those things. All right. তাহলে আর বলো, আর কোনো কোশ্চেন আছে কারো?
আর স্যার ওই আপনি যে গ্রাফ থিওরির যে পিডিএফ গুলো একবার যে দেবমাল্যকে সেন্ড করে দেবেন প্লিজ।
আচ্ছা, হ্যাঁ, সেন্ড করবো। তাহলে দুই একটা কারেকশন আছে, কারেকশন গুলো যেগুলো আমি পড়াতে গিয়ে দেখলাম একটু ভুল রয়ে গেছে, সেটা আমি সেটা কারেক্ট করে তোমাদের পাঠিয়ে দেবো। পাঠিয়ে দেবো তোমাদের, আমি গ্রুপ মেইলেই পাঠিয়ে দেবো, ঠিক আছে? তাহলে তোমরা সব গ্রুপ মেইলে যেখানে পাঠাই তোমাদের লিঙ্ক, সেখানে পাঠিয়ে দিলে তোমরা পেয়ে যাবে অলরেডি, ঠিক আছে? কাজে কিছু কিছু কারেকশন অলরেডি যেগুলো আমি মেনশন করেছিলাম, আমি সবকটা পাঠিয়ে দেবো। এবার ডিসকাস করতে গিয়ে আরো কিছু কি বলবো লেখার সময় ভুল হয়ে গেছে, সেইগুলো আমি মেনশন করেছিলাম, তো সেগুলো আমি আরেকবার চেক করে নিয়ে তোমাদের পাঠিয়ে দিচ্ছি। ওকে,
ওকে স্যার, থ্যাংক ইউ স্যার।
তাহলে আজকের মতো রোল করি, আর নেক্সট ক্লাস তাহলে আমাদের নেক্সট যেরকম আছে, আবার টিউসডেতে যেরকম আমরা ক্লাস করে থাকি, নেক্সট টিউসডে তাহলে আমরা আবার ক্লাস একই সময় 4:30 হবে। আমি সেখানে নন লিনিয়ার সার্কিট যেটা এখন অব্দি বাদ হয়েছে, দ্যাট আই শুড ডিসকাস। ওকে, আচ্ছা, তাহলে বলো। অর্পণ?
প্রেজেন্ট স্যার।
অরুণিম?
প্রেজেন্ট স্যার।
অসীম? অসীম সাহু? অসীম? অসীম দেখাচ্ছে না। বিনয়?
ইয়েস স্যার।
দেন দেবার্ঘ?
ইয়েস স্যার।
ঋষি?
Yes, sir.
ইমানুল? ইমানুল প্রেজেন্ট। ওকে, জাকওয়ান? জাকওয়ান প্রেজেন্ট। ওকে, গালিব? কাজী গালিব?
প্রেজেন্ট স্যার।
ওকে, ময়ূক?
প্রেজেন্ট স্যার।
পার্থ?
প্রেজেন্ট স্যার।
রেজওয়ান?
Present, sir.
দেন রিজওয়ান খান? রিজওয়ান? রিজওয়ান কোথায়? দেখাচ্ছে না। তারপরে হচ্ছে সুজুতি?
Present, sir.
ওকে, সোহম?
Present, sir.
ওকে, ও সুভাষিস হক দেখাচ্ছে প্রেজেন্ট। ওকে,
Present, sir.
সৌগত?
Yes, sir.
সৌগত?
Yes, sir.
Okay. সৌরভ?
Yes, sir.
দেন শুভজিৎ?
Yes, sir. Yes, sir.
Raj? Okay.
Yes, sir.
Okay. Anybody left who could not respond previously? রেজন শেখ? আচ্ছা, গেল। কে একজন যেন অসীম সাহু? অসীম সাহু কোথায়? দেখাচ্ছে না এখন। ওকে, সো থ্যাংক ইউ। থ্যাংক ইউ। পরের ক্লাসটা আমরা তাহলে নেক্সট আবার মঙ্গলবার দিন at 4:30। ওকে।